Okay, so I've been given this problem. The position in meters of a particle at any time in seconds is given by the function s of t, or displacement, is equal to 2t cubed minus 27t plus 15. The first part of the question, A, what are the functions for velocity and acceleration in terms of time? Okay, well, what I'm going to be explaining here in this and using this problem as a method of explanation is the relationship between displacement, velocity, and acceleration. And I'm going to use this problem to demonstrate it. So the first part, A, the function for velocity, or v of t, can be derived because velocity is the change in distance over the change in time. And the change in distance over the change in time is simply the differential or the derivative of the function for displacement, or s of t. So ds dt in this case is equal to 6t squared minus 27. Great. So that's the first part of this question. First part, velocity. Now we'll go on to acceleration. So acceleration, the relationship between acceleration and velocity is exactly the same as velocity and displacement. Acceleration, in terms of time, is measured in the change in a particle, an object's velocity over the change in time. So we can use similar notation, and we can say that acceleration is equal to the change in velocity over the change in time. So the derivative of velocity in terms of time, which is the derivative of this function, which turns out to be 12t. So here we have the functions for velocity and acceleration in terms of t. Cool. So now we'll go on to the next section. B. When is the particle at rest? Okay, so the particle is at rest when its velocity is 0. It's not going anywhere. So what we have to find is we have to find the values of t for when v of t is equal to 0. So what we're going to do here is we're going to input our velocity in terms of time function that we've just figured out. 6t squared minus 27 is equal to 0. And what I'm going to do here, I'm going to factorize the left-hand side by 3. Yep. Two t squared minus 9 equals 0. Now the setup here is you can factorize the inside here using a difference of perfect squares. So I'm going to write this as 3 outside of the square root of 2 times t plus 3, the square root of 2t minus 3. Equals 0. Cool. So what we can use now is we can use the null factor law. So I'm going to just denote that NFL for null factor law. T is going to have to be equal to either negative 3 over square root 2 or positive 3 over square root 2. So we can write plus or minus 3 over square root 2. Now, because it's measuring from a particular time, t equals 0 at initial time and then onwards, the negative 3 over square root 2 doesn't really make sense. So we can just write, therefore, v of t equals 0 when t is equal to 3 divided by square root 2 seconds. Great. So that's the sort of the solution for part B. C. What is the position or positions of the particle when it is at rest? Okay, so the position of this particle is determined using the function s in terms of t. We know there's only one time that it's at rest, which is at this particular time. So what we're going to do is we're just going to determine what s of 3 over square root 2 is. So we just substitute 3 over square root 2 into our function, and we have 2 bracket 3 over square root 2 cubed minus 27 in brackets 3 over square root 2 plus 15. Great. So what we're going to do here is we're going to go 3 over square root 2 cubed. So what that is going to equal is we're going to be able to get 2, because we do the power first, 3 cubed, which is 27, over square root 2 cubed. So square root 2 squared is 2, cubed is 2 times the square root of 2. So 2 square root 2 minus 27 times 3 is 81 over square root 2 plus 15. Great. So this 2 here, put it in a different colour to make it visible. This 2 here and the 2 down the bottom are going to cancel. So we're going to have that. And then we're going to be able to write this as 27 divided by the square root of 2 minus 81 over the square root of 2 plus 15, which is equal to 27 minus 81 is negative 54. Divided by the square root of 2 plus 15. So, when it is at rest, the position of this particle, so s of 3 over square root 2, I'll write therefore, s is equal to 15 minus 54 divided by the square root of 2 meters. The reason I put it in brackets is so you know that that's the exact value of my distance which I'm measuring in meters. Now, if you put that into your calculator, you'll find this is approximately equal to negative 23.18. So I think examiners in a sort of final year of high school, first year university calculus or physics class will be looking for the exact value, so you probably need to be presenting it like this. Okay, and finally D. Alright, so let's do D over here. What are the initial position, velocity, and acceleration of the particle? Okay, so initial is what that means is when time is equal to a 0. So what we're looking for, to be honest, is S of 0 for the initial position. So S of 0 is equal to 2 times 0 cubed minus 27 times 0 plus 15. So that's going to be equal to 0 minus 0 plus 15. So 15 meters. So that's the first one. The second one is V at 0. So we know that our velocity equation is here, 6t squared. So it's 6 0 squared minus 27. So that's going to be equal to negative 27 meters per second. And finally, acceleration at 0 is equal to 12 times 0, which is equal to 0 meters per second to the negative 2. So the three answers for the final part is that, and that. So those are our four solutions to this problem about position, velocity, and acceleration. The thing you need to take away from it is the link between displacement and velocity is that velocity is the derivative of displacement and acceleration is the derivative of velocity. So we can say, this is just me just recapping, we know that velocity is equal to the derivative of displacement, and we know that acceleration is equal to the derivative of velocity, or you can also say is the double derivative of displacement. So I hope that helps answer your questions about the relationship and how you can use calculus to move from having a function that deals with displacement to a function that deals with acceleration. And I'll see you next time.